Let's take a moment to understand how CrateDB solves the challenges associated with today's diverse data sources and the demands of modern systems or application development. When developing a system or application that needs to store and access data in a database, you'll often start by using a relational database system. Soon you realize you also need a search solution and add a search engine to the architecture. Now you have to manage data replication processes to keep that engine's data in sync with the relational database. Maybe you have a need to store complex objects or arbitrary JSON and streaming data from sensors. Adding a document store and time series database helps you to meet these needs. As your system grows, geospatial data becomes important, and you also need normalized abstractions for machine learning to work with embeddings. A vector store is added. In the end, you have a very complex architecture with a lot of data replication, different technologies, and multiple different languages in use for each of these technologies. This adds complexity to deployment, monitoring, and operations. It also creates additional development overhead due to the different query languages and data abstractions used by each data store in the system. There are issues and implications with adopting this sort of data architecture. Let's begin with the issues. Having a data store per use case requires data integration and synchronization. It's difficult to manage scaling up and out of multiple data stores, especially with time series databases. You also end up with a complex application backend because you're developing with different languages and in different data silos. This leads to a growing complexity and technical debt over time. The implications